And with 10.8, we're looking at one main thing in 10.8, and it's all about imaginary numbers or complex. And with imaginary numbers, the big thing that makes an imaginary number that's an imaginary number they specifically use the I variable. That in all the problems that you do when you're going through algebra, they pretty much never give you the I variable because they keep it separate because it's got this one special case where you use it here. And basically is this, what the I variable is, and kind of back up to this one, because this is where they kind of walk it into the first part of it here. So the problem will say something like this, use I to rewrite square roots. Of negative numbers. And that's really what imaginary numbers do, is that we talk about it using the I variable. And basically what that does is that tells you that the number you started off with square root was negative. Okay, so let's say you had something like this. They're going to ask you to simplify or use I to rewrite the square root of negative numbers. And you're going to start with square root of negative 25. All right, now if you check it with your calculator, it's going to give you no solution, right? Or give you an error message that if you try to square root 25, it tells you, no, that's not going to work. It's not, and when you do this, it's not a real answer, so they say, all right, this is why they call it an imaginary answer. And basically it's this. You're going to replace a negative inside the square root with I squared. And the whole big thing that you're looking at for this part, this is what the whole section of chapter 10.8 looks at, is that I squared equals negative 1. They're going to reuse that thing over and over and over and over when we go through all the parts here. And it's always written as a script I, where, you know, it's not just, you hardly ever see it where it's just an I like that. They always put it with the little script on it there, so it's got the italicized. That's what I was looking for. All right, so what we're going to do here is that if you had the square root of negative 25, you're going to take out that negative and you're going to replace it with I squared. And so it's basically going to be I squared times 25. If you have a negative 25, you take the negative out and you replace it with I squared. Because technically that's a negative 1. It's like negative 1 times 25 is the way they think about it. And then what you can do is, if you break that up into two parts, what is the square root of I squared? Square and square root cancel, right? That's just I. And if you square root 25, well, that's 5. Now, in the way they always write the complex numbers is they always put the number first, just like it was like a regular variable. So your answer for that one would be 5i. And the I is a marker to let you know that, okay, when we started this problem with square roots, that meant that there was a negative inside the square root. So the I just lets you know, okay, this is not a real number solution. They put the I in there to let you know this is imaginary because it started off with a negative number inside the square root. All right, so if they give you square root of negative 18, We got square root of, and if you want to for this one, you could even just take the negative out. If you want to just go ahead and make it the square root of 18i squared and just put that I squared behind it, so it's already kind of lined up there. Most of the time, that's the way you're going to see it. So it's the square root of 18 and the square root of I squared. Let's go ahead and break them up in two parts. Square root of 18 would be 9 times 2. Square root of 9 is 3. Square root of 2. And when you square the I squared, that would be an I that goes on the outside. Okay, now, most of the time on these, when you're doing this one, again, if you just did square root of 18, that answer would be 3 square root of 2. So the only difference between the positive and negative is you have to put the I in there as a marker. And most of the time with that I, they usually put it in front of the square root. So the way you're going to see that written is they're going to write it as 3i squared of 2. They might let you get away with the I on the end of it. As long as it's not inside the square root, they may let you slide by on it. But most of the time they put that out front so that there's no confusion about is that I in the square root or is it outside the square root. That I is always going to be outside the square root. It won't let you do it? Okay, so this will not work. You have to go there. Okay. And I know sometimes later on when we do these, sometimes they'll let you, some problems they'll let you put it there. But it just, I guess it depends on the problem. All right, let's go negative square root of negative 40. All right, and as soon as you see the negative, again, you're basically got that that's the I squared. And you could almost, once you know it's there, you could almost really skip that and think about that that's going to be negative I squared of 40. Because you know you're going to square it I squared to make it I, because that I is your marker that's imaginary. And really now you're just breaking down the 40. Probably the easiest way is to do 4 times 10. You can take the square root of 4 and make that a 2, so that's a negative 2i square root of 10. Again, the negative out front is just the negative that's out front. You can kind of ignore it and just put in the answer. And again, if you think about the square root of 40, if you were just to break it down, again, you could do 4 times 10, so that would be 2 square root of 10. The only difference is again, if it's imaginary, you know you got to put the I marker in there. If the negative's there, it just hangs out front. Okay, so that's the first part where they just get you used to going from, all right, now instead of saying no solution, now you get a solution. The only difference is instead of an answer just being the answer, you just put the I in there, and that's a marker to let you know, okay, it started off as a negative. All right, once you've had a chance on a few of those, you're going to simplify. A product and or a quotient. I think they package these two together. Really, you're doing a product on one, then you're doing a quotient on the other, but they package these together where it's one problem. And it's still that same thing. It's still the square root of a negative number. So they're just going to keep coming back to that same theme over and over and over for all these. Okay, now here's one of those cases where it's a 50-50 kind of problem. If you just did these normally and didn't worry about the I variable, depending on the problem, sometimes you get the right answer, sometimes you don't. Here's the biggest thing with these. Before you do anything, Well, let's not say eliminate, sorry. Rewrite it would be a better way of saying that. So the first thing you're going to do is you're going to rewrite the square root using I in place of the negative. Okay, and then we'll say you're simplify, because some of these you're going to add, some of these you're going to multiply, some of these you're going to divide. But the biggest thing on this one is before you do anything at all, you've got to rewrite the square root without the negative number that's in there. So for this one, the very first thing you'd have to do is take out this 24. And again, as soon as you see a negative, just put an I on the outside. I mean, that's really what it comes down to. So it's I times the square root of 24 over I times the square root of 2. Okay. Once you've taken out the negative and replaced it with an I on the outside of the square root, then you work on simplifying it. What happens with the I over I? Cancels out. So really you're stuck with square root of 24 over 12, and those two things will simplify, right? So if you do 24 divided by 12, that is the square root of 12. Now you can just take the 12 and break it down, which is 4 times 3. Square root of 4 is 2. And for that one, if you don't take out the, and somebody might say, well, if we just took negative 24 and divided by negative 12, wouldn't we have just gotten 12 anyway? In that case, yes. So with division, it actually works out okay. It cancels itself out, but that's technically what we're supposed to do. On multiplication, if you don't do that replacement, you're going to get the wrong answer. So division, it kind of works its way out. When you do multiplication, if you don't do it, now the answer is only going to be off by one tiny, tiny, tiny little thing, but it's going to be enough of a little thing that it's going to throw off your answer. Okay, so multiplication. It's negative 3 times negative 15. All right, and then the very first thing you want to do again is take out the negative, replace it with an I. Take out this negative and replace it with an I. Now, here's where the difference comes on this one. If you do 3 times 15, that is 45. But on the outside, what happens when you do I times I? That is I squared. And if you have an I squared, the very first thing we said back up here at the top is that if you get I squared, you can always take an I squared and replace it with negative 1. So for this one, you're going to take out this I squared and replace that with negative 1. Now, the 45, you're going to go ahead and break it down just like you normally would do. 45 would be 9 times 5. Square of 9 is 3. So you have negative 1 times 3 times the square root of 5. And if you do negative 1 times 3, that's a negative 3 square root of 5. And here's where you would miss this one. If you just did negative 3 times negative 5, that would have been a positive 45. You would have gotten rid of the I squared altogether. So the difference in that one is this one, the answer is negative, where if you didn't do the I squared replacement, you would have had just 3 squared of 5. So and now it's only that negative sign out front that would make it miss, but it's enough that you're going to miss it every single time if you don't do that. It's not a big deal. And again, division, it works its way out because of how the i's cancel each other out. With multiplication, they don't cancel. You do I times I to get I squared, and with the I squared, you make it negative 1, which makes the answer negative every single time. Okay. Now, I could give you more problems, but they're all exactly the same way. Every single time when you do the division, it's going to be just a regular number. every single time when you do the multiplication, it's going to be the negative of whatever that answer is that you would normally kind of do for that part of it. No, actually, let me give you one more. Got just enough room right here. Now, I'm not going to do one with division. Let me give you one with multiplication. Do square root of 45, not 9, hang on. No, let's make that 6. So square root of negative 45 times the square root of 6. Because if I did square root of 9, that would be 3. That's not really need to do it that one. Okay, very first thing is, again, you've got the negative here. Go ahead and take the I out. So that way you know this was negative. So it's I squared of 45 times square root of 6. If there's only one negative, that I is going to be in your answer. So now 45 times 6 is going to be a pretty big number. So let's go ahead and just kind of start breaking that one down like it is. You do 9 times 5, which would be 2 times 3. That's 3 times 3. That's 3, 3, 5, 2, and a 3. Two, 3, 3, 3, 5. Now again, you could, if you want to multiply it back together, make it 45 times 6, where it would be 270. You're going to have to break the 270 down, so it might be quicker just to leave it as those two numbers and then go ahead and kind of break it down. And for this one, you do have a pair of 3s. So you can take that 3 on the outside. The I was already here. We'll put it there. There's no pairs of 2s, 3s, or 5s left over, so we're just going to multiply those numbers together. 2 times 3 is 6. 6 times 5 is square root of 30. Okay, so if you only have one number, the I is going to be left in there, and that's the same way with division. If you happen to do division and there's only one number that you're dividing by, the I's are not going to cancel. The I is just going to be left in your answer when you go through it. Okay, and that's pretty much it. Either they give you 2 negatives or they give you 1, and it's just a matter of, what you do with the 2 negatives. If you get 2 negatives, sometimes you multiply them, sometimes they cancel. If you get 1, it's pretty much stuck that you're going to have I on the answer when you go through that. Okay, addition and subtraction with complex numbers. The good news is on this one is there's no big rules you have to worry about. You just combine like terms. So when you get through this one, you don't have to worry about any substitutions, any replacements. For this one, you just simply combine like terms. Okay, so you may have something like this where you've got negative 5i plus 3 plus 4i. And if you've got a plus, you really don't have anything that happens. There's no distributive property, anything here. So really this is just negative 5i. Get rid of the parentheses. We've got a plus 3 and then plus 4i. Okay, your like terms are the negative 4 and the plus, or negative 5 and the plus 4. So the 3 is okay. If you do negative 5 plus 4, that's negative 1i. But the negative 1 is just like if you're doing x, you don't have to put the 1 there, so you can just say that that's 3 minus I. Now with these, they do add in one small little detail here. And it's really just more of how you write the answer. Is complex form, and that's a plus bi. Or sometimes it's called a plus bi form, which basically just means you put the real number first, and then the imaginary part of the I part goes second. Okay. Again, not a big deal. Just when you rewrite, if they ask you to write the problem and they ask you to put it in a plus bi form, sometimes they call this standard form. So that may be another way that they talk about it. A plus bi, complex form, standard form. It's all the same thing. They may just say it a couple of different ways. Okay, now addition. There's really no tricks to it. The only one that you have to be the least little bit careful is when you do subtraction. Okay, so let's say you have 6i minus 3 minus 4i. Everybody gets this part correct. They'll do the 6i, they'll do the minus 3. But what happens when you do the minus the negative 4i? There you go. That's the part that most people forget about, is that if you do minus a negative on that second part, that's a plus 4. That really, when you see those problems with a subtraction, you really have to think that that is negative 1 times 3, and it's negative 1 times negative 4. That you have to change both of the signs. So you're changing this to a minus, and then you're changing that one to a plus. And then once you do that, now you just combine your like terms. You've got 6i plus 4i. So that would be a 10i, and then the negative 3 is going to go first. Okay. And with addition and subtraction, that's pretty much it. The only thing you have to be the least little bit careful of is the subtraction problems, because you have to change both of the signs. Again, most people get the first one. It's always that second one that we get a little lazy on sometimes, and we forget to go back and change it. Let's give you one more of those just to make sure we're good. All right, so let's go with negative 2 plus 3i, and minus negative 1 plus 4i. Okay, again, first part out in front of the negative. If they give you, and most times they give you these with parentheses. First parentheses doesn't change. It's the second one. If you do minus a negative, that's a plus 1. If you do minus the 4i, that's a negative or a minus 4i. Okay, so for the I part of it, you've got 3 minus 4, that's a negative 1i. And for your whole numbers, you've got a negative 2 plus 1. So that's a negative 1. So it's negative 1 minus negative 1i. And again, if it's just the one that's with the I, you don't need it. So it's just negative 1 minus I. Oh, let me do one more thing here, because this may pop up. Just now thought of it. I'm going to make this one go really quick. Okay, let's say you've got 4 minus 3i plus 3i. Because it's a plus, you don't have to change anything at all about the parentheses. What happens when you do the negative 3 plus 3? It's 0, right? So if you get a 0i, that you don't really need it. So for that one, your answer would just be 4. Now, I don't think, and I didn't see any problems that popped up this way, but I don't think they're going to make you write the answer as 4 plus 0i, because technically the 0 doesn't have a plus or a minus. It's sign neutral. So for that one, they shouldn't give you this. It should just be, the answer should just be 4. Because the 0 doesn't have a sign at all, so they really can't put a plus with it or a minus with it. Okay. So with addition and subtraction, just combining like terms. When you multiply complex numbers, now this could either be distributive property or it could be the full method. It's still the exact same thing as if you were doing distributive property or full method. Nothing really changes. The only difference is if you get I squared, then you have to replace I squared with negative 1. Everything else, you do it exactly the same. You do the full method, you do distributive property, you do whatever the problem tells you to do. Unless you get I squared, then you have to take the I squared out and replace that with a negative 1. Okay, so let's give you one distributive property and then one with full method. All right, doing distributive property. It's negative 4 times negative 6, so that's a positive 24. There's only the one I, so it's going to stay I. On the second part, when you do negative 4 times basically a 1, it's negative 4. When you do I times I, it is I squared. Okay, 24i is good, but with the I squared for this one, you do have to take out the I squared and replace it with negative 1. So when you do negative 4 times negative 1, that makes it a positive 4. Now, that's your answer. It's not in standard form or complex form or wherever they want to say it. So you just have to rearrange the answer, put the 4 first, and then put the 24i second. And that's the answer you're looking for. Yeah, so the exact same properties, you multiply the numbers. If you have exponents, if you do I times I, you've got to make it I squared. Just like if you did x times x, you'd make it x squared. So that part of it's going to be exactly the same, nothing different there. And it's only one of two things. It's either distributive property or it's the full method. We'll go through the full method one real quick. So let's go with negative 6 minus 3i, and then times negative 1 plus 5i. Okay, so multiply everything through by the negative 6. Negative 6 times negative 1 is a positive 6. Negative 6 times 5 is a negative 30i. Multiplying everything by negative 3i, negative times negative is a positive 3i. Negative times a positive is a negative 15. And when you do I times I, that is I squared. Okay, and just like when we did the distributive property, where you have the I squared, you have to take out the I squared and replace it with negative 1. And the middle two terms, you can always add or subtract those together. So the 6 is good. When you do negative 30 plus 3, that's a negative 27. I. And when you do negative 15 times negative 1, it's going to make that a positive 15. Okay, and then you've got the 6 plus 15. So then you can put the 6 plus 15 together and make that 21. And then you've got the minus 27i. Okay, and then two last things. So again, multiplication is pretty straightforward. The only thing you have to watch out for is the I squared, that you replace that with a -1. But it's still distributive property, it's still full method. Nothing really changes other than if you have the I squared, you replace that with a -1. With division, so we've got 2i over -6 minus 4i. Now, I hate to say that division is really not a division problem, because it's really not a division problem. It's almost like what we did back in section 6. When we had the square roots in the bottom, how we rationalized the denominator by multiplying by the conjugate. Same thing on this one. You're going to multiply by the conjugate of the denominator. So even though it's a division problem, it's really not a division problem. It's more that it's a multiplication problem where you have to multiply by the conjugate of the denominator. So we're going to do -6. Instead of minus 4i, we're going to do -6 plus 4i. Okay, and just like in section 6, when we're putting parentheses around it and going back and doing the exact same thing here, it's just now instead of the denominator being a square root and we're rationalizing, it's almost like we're rationalizing again and getting rid of the I that's in the bottom part of it. Okay, top part. Again, really nothing you can do with this one. It's just distributive property. So that is -12i. 2i times 4 would be 8i squared. And again, with the I squared, let's go ahead and stick with that part first. Do -12i, take out the I squared, replace it with -1. That would be a -12i minus 8. But again, you have to put the real number first, so we'll put the 8 first, and then -12i second. Okay, and with the conjugates, when you do the full method again, the O and the I cancel each other out. It's just -6 times -6, which would be a positive 36. When you do -4i times positive 4i, that's going to be a -16i squared. But again, when you get the I squared, replace it with -1. That's 36 plus 16. Add those two together and get 52. Now, here's where they contradict themselves from what they had been doing earlier. And here's where I didn't like that they did this back in section 6. In section 6, they made you keep this as one big fraction. In this section, now they actually separate it into two different parts. So you're going to have to think that this one is really -8 over 52 minus 12i over 52. So once you get it down to the numbers, you actually have to separate it into two separate fractions. And you simplify each piece as much as you can. Looks like you're going to divide them both by 4. So that would be if you divide these by 4, that's going to make that a negative 2 over 13. And with 12 and 52, you're going to divide those both by 4. So it wind up being the same number. So that's minus, that's going to be 3, another 13. And with the I variable, they actually want you to put that separate kind of out on the end there. If you put it in the top, it might be okay. But I think a lot of times they kind of want it separate on the end. That's the way they show it here. I think they really want it on the end off by itself. One more of those? Or is it okay? So it's okay. Okay. The only thing they can do different is that the top number, just like it was when you're rationalizing, instead of it being 2, it might be 3 plus 2i. So then you're doing the full method on the bottom and you're doing the full method on top. But it's still that same thing if you're still just multiplying the numbers out, kind of working with it. All right, last thing you got to look at is you're going to simplify powers of I. All right, so here's what you're going to do. Let's say you got something like I to the 19th. And it's almost one of those you almost have to kind of have a all right. Flashback to exponents. Anything to the 0 power, anything at all with 0 power is 1. So what they kind of do is they say, all right, with powers of I, if we think back to the basics on these, anything, doesn't matter what the number is, anything to the 0 power is 1. If you do anything to the first power, it's just itself. The definition they gave us was that I squared was negative 1. And once we get to I to the third, they tell you, all right, well, basically I to the third would be rewritten as I to the first times I squared. And so if you multiply those two together, that's I times negative 1. So really this thing is just going to be negative I. So now if you get to I to the fourth, and this is where it's going to, and this is part you don't have to know, but just kind of watching this one. If you get to I to the fourth, you can rewrite that as I squared times I squared, which means this is negative 1 times negative 1, which would be a positive 1, which gets you right back to here, and then you're just going to keep repeating through this one. So basically, here's what it is. This is your remainder. This thing highlighted is going to be our answer. So here's what you're going to do. You're going to divide the power by 4. Whatever the remainder is tells you what the answer is going to be. So it's almost like we could make a little box here. So if your remainder is 0, your answer is going to be like we had the 0 power. Your answer is going to be 1. your remainder is 1, your answer is going to be I. If your remainder is 2, your answer is -1. If your remainder is 3, your answer is going to be -I. Okay. And that's pretty much your chart. So if it's I the 19th, you're going to take 19 and divide it by 4. 4 going to 19 4 times. Oh, just from this problem right here. So you're going to take 4 and divide it into this power. 4 going to 19 4 times with 3 left over. And since 3 is your remainder, if your remainder is 3, your answer is -I. So when I ask you for this one, -I is going to be your answer. Actually, let's put that down here at the bottom. Okay, now once you've got the chart, and you've got this little chart that's here, they can give you any single problem that you want to work out from here. And it goes a whole lot quicker once you get past this. So anybody give me I to any big number. Don't go past 1,000. 500. So if you have I to the 500, all you're going to do is you're going to take 4 and divide it into 500. That's 10. 4 going to 10 2 times. That's 8. That's 2. 4 go evenly into 20. You get a 0 remainder, right? If your remainder is 0, go back to your chart. Your answer is 1. There's your answer. That's all you're going to do. So all you really need when you're doing those is this chart, and all you're going to do is you're going to take whatever the exponent is, divide it by 4, whatever the remainder is, just go back to the chart. If your remainder is 0, your answer is going to be 1. If your remainder was 3, the answer was -I. If your remainder is 1, it's just I. And they give you a 4 bubble option to pick one of those 4 answers of 1, I, -1, or -I, and you just got to pick the right answer and just bubble it in.